Hello friends, welcome back to my channel. My name is Kapil and today in this video we will discuss about the flow control frame basically, okay, and the main thing is the PCI control information or PCI control byte, okay. So how we'll interpret this in the UDS that we will going to see. So first point, I think we already seen in the last video that there are different types of frame which is available in CAN. One is the single frame, first frame, consecutive frame, and flow control. Okay, so this is the basically the for the single frame we will use the first basically the this first byte actually zero, and then this is the size. So basically the we are going to use the byte zero for that. Okay, and for the first frame we will use the this first nibble, then second nibble, and there's basically these 12 bits to indicate the first frame. Okay, and the consecutive frame basically will indicate the first nibble 2, then we will have a next nibble which is it starting from 0 to ff, basically 0 to 15, and for the flow control basically the 3 is in first nibble, then we have FC flag, okay, 0 1 2, which will be the possible value there, and then next byte will be the block size, and then st. So I think this will not be much clear. We can just go through the next slide, and then maybe you will be able to understand much better. So just remember this is the very informative first 2 3 slide, then you we will use the application of this in the next slide. The first frame indicate, let's say you just need to remember that single frame which the code for the single frame is 0, code for the first frame is 1, code for the consecutive frame is 2, and for the flow control it is 3. Okay, so basically this is the nibble which we are going to use, and then we have the following information, but we will detailed in the detail we'll see this. So let's go to the next. So now we will first try to understand the flow control. Generally you see the flow control will have the value 3000 and 00. Okay, so what is mean by that? So as we understood, the first nibble, which is the first nibble 3, which is used for the indication as in the flow control frame. Okay, so that is type 3, basically flow control frame, which is nibble by bit 4 to 7. Then bit 0 to 3 is basically indicate if we have a 0, that means it indicate the continue to send. So we are allowed, we can continue to send the bytes. 1 means wait, basically we need to wait. Okay, and the second is basically overflow or abort. Okay, we need to either abort the operation, it is indicate the overflow. So then the next in is the 0. If we have the then basically remaining byte to be sent without flow control or any delay. So this is what we are going to understand now. So this is the block size bytes, and the block size byte, if it is 0, then we can send all the consecutive frame as it is. Okay, we need not to wait for that actually. But if it is other than that value, let's say 4, then 4 consecutive frame we can send, and after that again we need to have a flow control where it will indicate, okay, now again you can send it. Okay, so that's why this flow control is being used, and it is very important. Generally it is being configured as a 00, so all the consecutive frame can be sent again and again back to back. But if we have some values 4 or 5, then all only 4 consecutive frame needs to be sent, and then later on again we should wait for the flow control byte to indicate that we are good to go ahead. Estimin is very important factor again, so which will indicate the time interval between the reception of the one frame and starting the sending of the other frame. So which will also have the indication. So generally the value which is being used here is below 2, or let's say less than or equal to 127, so which will be in the millisecond. So 1 is indicating 1 millisecond, 2 will indicate 2 millisecond, 10 will indicate 10 milliseconds. So we should have this gap in between. Okay, so that's why st is being used, but generally also it is being configured as a 00, which will indicate that it is the shortest time basically you should go for it. And F1 to F9 is specific case where you it will indicate from 100 to 900 microsecond. F1 is 100 and F9 is 900 microseconds. Basically it is indicating the special case of 100 to 900 microsecond as the minimum time interval. Okay, then what is block size? I think we already got, but the what is the definition, that is very important to know. So that's why the count, the what is the block size? The count of frames that may be sent before waiting for the next flow control frame. Okay, so that's what I told. Depending on that count, if you have a four, then you can send the flow four consecutive frames. A value of 0 allowed the remaining frames to be sent without flow control delay. So then we can send without any delay. Again, stmin definition is also important. Stmin is basically separation time, the minimum delay between the frames. St value up to 127, I think whatever we said, that is the same which is being mentioned over here. And the next one is the note that the separation time is defined as a minimum time between the end of the one frame to the beginning of the next frame. So that's what I told, end of the one frame to the beginning of the next frame. Next one is the BS block size. I already mentioned about this, but yeah, we can see, we can repeat this again. So BS is because generally people will do not know about this. That's why I said that BS is equal to 0, estimate is equal to 0. And I found out the reference where it is indicating, it is saying that it is what exactly it mean. So you see that the BS, the block size is 0, then is the requested number of frame to be to send per block between the flow control frame is 0. 0 is is equal to no limit, you can send continuously consecutive frames. Separation time, estimate requested minimum separation time between the each frame in a block, but special case is 0, send as fast as possible. Okay, generally let's say if we have only, we are sending 3 or 4 byte, then we have a padding character as well which will be filled. Let's say if we are sending 3 byte, then remaining will be filled with the yeah specific character, whatever the character we are deciding. So in this example you can see the padding is none, that's why we will see the 0 0 by default. But if we have specific padding which needs to be used at BB, then yeah, it is basically it is useful. So then we will fill all the remaining byte with the BB. So this is what again, now let's consider a few example which confirms our understandings. That's why I added this example. So you see the example, maybe you can correct if I am going somewhere wrong, but yeah, this is my understanding and I believe it is correct. So yeah, you can see that example BS is equal to 4, estimate is equal to 2 milliseconds. So this is the time. If you see that st minim, so this is the end of the one frame and this is the beginning of the new frame. So that's why this timing is basically in between timing is 2 millisecond. I just give an example. So whatever the value you specified, that should be there. And BS is equal to 4. Let's say one, the what, how many consecutive frame we are sending? 1 2 3 4. And then again we are sending the yeah basically flow control. That's why, so we are allowed to send 4 consecutive frame, and then again we request the flow control byte, and then we can send the other byte. So that's why we say that BS is equal to 4. Yeah, one more example. We will take few more examples to confirm our understanding, and to yeah, you it will be useful for you as well. So 30 0 1 and 1 4. So 30 is indicating the flow control byte. Okay, 0 means continue to send. Then 0A is equal to basically block size, and block size is equal to 10. 10 is indicating the 10 consecutive can be sent. 1 4 is basically the is in hex is equal to 20 decimal. 20 decimal means 20 millisecond is the estimated time, and this is the AAA is basically padded characters which we have decided to go ahead. Next is one more example. Let's say if we now go into the Kano and then see what exactly is the happening there. We have taken this example. So 10 12 2, this is the frame. So 10 12, basically 10 indicate the first frame. So basically 10 is first, 1 is indicating 1, first nibble is indicating 1 is first frame. Then 0 1 2 is basically indicating the size basically. Okay, so 0 1 2 is the size. in hexadecimal, then 2E is the SID, and then 1A to B is DID. Okay, then we have the data frame. Basically, we have some data in the first frame itself, so that's why 3 byte of data we are sending over here. Okay, and then we are getting the flow control from the opposite direction, that is indicating 0 3 0, then 0 0 basically. So it indicate where 3 is flow control, 0 means yeah continue to send, then 0 0 means block size is 0, 0 means st mean is 0 0. I think I don't know why this third additional byte is there, but yeah, let's go ahead. This 2 1, so 2 1 is basically first consecutive frame. So generally they will ask one more question, that why it is 2 1, why it is not 2 0. So because this is the first frame which it indicate the first frame, basically which is the first frame. So that's why this is second frame, and therefore second frame it should start from 2 2. If it is first frame, then only it should start. That is the logic basically. But yeah, that is the logic basically. It is our way of implementation. We are always sending 2 1 in the consecutive frame. So 2 1, then we have the remaining bytes, then 2 2 2 3. Okay, so let's say how many. So this is 7 7 7. So let's go ahead and take calculator. Okay, so 7 7 7. Okay, I need to go back. 7 7 7 21, 22, 23, 24. Okay, so 24 bytes. So I think yeah, ideally it should match. So we are sending 24 bytes. But yeah, but here you see that out of that 1 2 3 4, 1 2 3 and 5 6 6. So 24 minus 6 means 18. So 18 is the 12 is basically 18. So it is correct. So I think it is matching. Yeah. Okay, fine. So that's why it is 12 over here. So 16 plus 2 it is 18, and then it is yeah it is 10. So yeah, then we are sending the consecutive frame. Then we have this additional things where it is new request. But yeah, let's go ahead. Then we have one more example, that is 0322 FF1B 03 basically the first frame, then 22 SID, FF1B is DID. Then in response we are getting yeah basically request. Basically here the request is simple, but response we are sending multiple bytes. Okay, that is the case over here. It is slightly different than other case. So 10 is the first indicates the first frame, then 028 is our total length. So first nibble, this nibble plus total 12 bits basically, that is the PCI control byte. Then the 62 is positive response, then FF1B is requested DID. Okay, so this is the way we are sending the response. Then we will have the consecutive yeah, we will get the flow control basically, and then we will send the yeah consecutive frame as well. So consecutive frame basically here 40 bytes. You can see that 7 7 7 7 7 7 multiplied by 35, 35 plus 1 2 3 4, 1 2 3 4 5 means 40 bytes. Okay, so that's why it is equal to 40. Okay, and here you see how many byte, 1 2 3 4 5. Okay, I don't know here, there is something is suspicious. I understood that, but yeah, I think there should be some 3 bytes needs to be sent over here as well. But yeah, overall it is yeah, so 26. Okay, and there will be a 2 byte. I think will be 1 2 3 4 5 6 7 8. So I think 3 byte will be sent there as well. Okay, so I think it all together it should come 28. Okay, 28 in the hexadecimal. So I understood there's 16 plus 16, 32, 32 plus 8 is means 14, 40. So altogether it should be 40. Okay, that's what is the interpretation. So that's all for this video. I hope you like this. This is detailed video. That's why I went to, because generally if you read go through one video, it will not be sufficient to understand each and everything. That's why I make this detailed video. Thanks for watching. If you are still here, definitely I would request you to subscribe and press like icon. Thank you.